Hello, welcome to Easy as Pilot, Mr. Carpenter. I am Mr. Carpenter. That has not changed. And today is going to be a brief overview, on the difference of perfect squares, also known as DOPS. So if at this point in the year, DOPS is still something that you struggle with, then this video can kind of be a walkthrough for you on the steps that you're doing in order to factor this out. So let's start with a very basic one. And before we start with that basic one, we need to think of the criteria that we have to satisfy to be able to do DOPS in the first place, right? So what tells us we can do DOPS? Well, first of all, it's a binomial, which means two terms. Second thing is there's a minus sign in the middle, so subtraction. We cannot do DOPS if it's an adding. And number three, everything is a perfect square. So that means when I take a square root, I get a nice number. I don't get a bunch of infinite decimals that are all over the place, right? For example, x squared minus 9. It is a binomial because there's two terms. There is a minus sign in the middle, so that takes care of number 2. And these are both perfect squares, right? Because this has a squared in it, so obviously that's a perfect square. And if I take the square root of 9, I would get 3 in my calculator. So that is also a perfect square. And from here, once we satisfied all these criteria, we have to do 2 steps in order to factor with DOPS. The first thing is we need to rewrite every number as a number squared, right? And what I mean by that is this is x squared. So it's written as some number raised to the power of 2. That's what I want for every number. So for that 9, I know the square root of 9 is 3. So I could rewrite this 9 as 3 times 3, because 3 times 3 is 9. Or in other words, I could write this as 3 squared. So I took the square root of 9, and it got me 3, so I know that I can rewrite 9 as 3 squared. And when you cover up the squares with your hand, or you just look at the bases, right, what you see is x minus 3. So I'm going to write x minus 3, and then I pair it up with its best friend, x plus 3, and that would be factoring with DOPS. And this is correctly factored because if you were to multiply this polynomial, x times x is x squared, x times 3 is 3x, negative 3 times x is negative 3x, and negative 3 times 3 is negative 9. And these will cancel out, and you are right back where you started. So this is correctly factored. So let's look at one more. That's just a little more complicated, right? It doesn't really get too much more complicated with DOPS. The only real wrench in the operation that I could throw is something like this. Now, you will say that we could do greatest common factor here. And the answer is yes, we could do greatest common factor, but we don't have to, right? We could just go straight into DOPS because it is a binomial, 2 terms. There's a minus sign in the middle. And these are all perfect squares, right? I take the square root of 16, and that would be 4. And I take the square root of 64, and that would be 8. So what do I have to do? I have to rewrite every term as a number squared. So 16, and this is the one that everyone forgets, is this one right there. You have to rewrite every number, right? Because the base of this exponent of 2 is just the x. So this 16 is still not written in this moment as a number squared. So 16 is the same as 4 squared. And there's my x squared minus 64, well, the square root of 64 is 8, so I can rewrite that as 8 squared. And then we just do the same thing we did before. I cover up the squares, and I see 4x minus 8. So I can write this as 4x minus 8, and I pair it up with its best friend, 4x plus 8. And I am all done. And just for fun, right, in case you said, well, what if I did take that greatest common factor at the beginning? Does that mean I can't do DOPS anymore? Absolutely not. If you can do greatest common factor and you can do DOPS, then you could also do both. For example, right here, I could factor out, I believe I can factor out a 16. I don't know why I'm forgetting if 64 is divisible by 16. It almost certainly is. Yes, it is. So yeah, we can factor out a 16. 16 divided by 16 is 1, so those cancel out, and I'm left with the x squared minus 64 divided by 16 is 4. And this is also a difference of perfect squares, because the square root of 4 is 2, so it'll be minus 2 squared, which would factor out to x minus 2, x plus 2. And that would also be a sufficient way to factor using the difference of perfect squares. And that is all I have for you. Thank you very much for watching, and I will see you on the next one.